share my screen so that you can see what I'm looking at. All righty. So on 22, it says the number of acres in the United States is used for an organic apple production from 2000 to 2005 and can be modeled by a to the x, which is equal to 43.77x to the fourth minus 498.76x cubed plus 1310.2x squared plus 1626.2x plus 6821.5, where x is equal to 0 as the year 2000. So the first one says graph this using a graphing calculator. So I'll pull up my Desmos real quick. I already had one plugged in. So 43.77x to the fourth minus 498x third plus 1626x plus 6821. Okay. It's way up here. And the hardest part about this is really finding an area at which the graph actually appears. You can see I'm having to scroll all the way up in Desmos. Okay, so here's my graph. So if it lets me zoom in, and the reason I went all the way up to 6800 is because of that constant at the very end, that 0.6821.5. So it doesn't matter. Polynomial functions, the same way that quadratic functions work, we always have a constant which acts as the y-intercept, right? And the constant is always typically at the end, because when we plug in a 0 for all those x's, when we're multiplying all of that out, everything that's associated with a variable will normally turn to 0. So we're always just left with that constant. Still got to get there. I swear my arm's going to fall off from having to do this. But we're getting closer. 676. Okay. So right about here is my y-intercept. This 6028.21. And that's going to function as year 0. Once again, this one's not necessarily the most difficult because we're just asked to graph it. But if we scroll in, they want a window between 1 to 5. You can see we're going to be right here as the y-intercept. And then our graph continues out. Okay, so even though it's not a good picture of our graph, we can see it. But we can tell a lot about this equation just by knowing what we know about our leading term test and what our coefficient is. So the graphing it, the hardest part is trying to find the window and making sure that we plug it in correctly. Okay, that was step A. So we've done that. Do we have the greatest picture of it? No. Right, we would have to mess around and find the window. But whenever you're given a question where it's asking you to graph, be sure that we're reading the follow-up questions. Like, what do they want us to find here? Okay, so here it just says we want to graph the function using a graphing calculator, but then question B is describe the end behavior of the graph using limits. Explain this using the leading term test. So my question to you guys is, did we really even have to graph this equation to answer B? And the answer to that would be no, because end behavior is all determined based upon this term, right? Is this value of A, which in this case is 43.77, is that a positive or a negative? Okay, in this case, it's positive. We have a positive value for A. And then we want to pay attention to what is the degree. And the degree is 4, which is even. So if we remember from power functions or the leading term test of the polynomial equation, we can describe exactly what the end behavior is going to be here. Since our value of a is positive, and we have a degree of 4, which is even, the limit as x goes towards a negative infinity, f of x equals a positive infinity, and the limit as f of x, or as x goes towards a positive infinity, f of x also goes to a positive infinity. And that's because based upon this 43.77, x to the 4th, we know that our graph at the ends, both ends, are going to be shaped like this. Okay, they're going to be going up. If this was a negative value, then they would be going down. So that would be if a is negative and if a is positive. And like I said, the hardest part about the graphing part of it is really just finding a window big enough that fits, right? And I think on the solution guide, they wanted you to use 0 to 5, and honestly, they're probably using a y value. If I had a graphing calculator, plug it in, I only have it with Desmos. But they're probably using y's that go all the way up to 10 or 15,000, but they've shrunk down their x-axis so that you can actually see the interior of the graph. Unfortunately, using Desmos, I don't really get that opportunity. I might be able to. Y-axis. Okay, let's go to like 25,000. See if that does anything. Just playing around real quick. Now, because every time we zoom out, okay. Yeah, Desmos makes that very difficult to do. It's one of the downfalls to Desmos, even though it's nice that we can graph stuff. But graphing calculators, you can actually set steps on where your x-axis begins, where your y-axis begins. So that would be a useful thing to accomplish this problem. But like I said, to answer B, the true question, we don't even really need to graph it to be able to do that, because we know from our leading term what our end behavior should look like. Okay, so off to 32. This is going to be tough. So 32 says state the number of possible real zeros and turning points of each function, then determine all the real zeros by factoring. And we are given 3x to the 5th plus 11x to the 4th minus 20x cubed. Okay, so this one will fit the quadratic form, but the first question we have to try to solve is what is our greatest common factor that appears between all three of these terms? So we always want to look at the coefficient and see if we can bring that out to be able to make it a little easier for us. So we have 3, 11, and 20. Unfortunately, 2 of those numbers are prime, so we can't factor out any of the coefficients, but we can factor out the variables, and the highest degree that we could factor out is x cubed. Okay, so x cubed divided into 3x to the 5th is going to give us 3x squared. That's going to give us plus 11x, and that's going to give us minus 20. Okay, so I imagine this is where your question actually kicks in, Leah, because you asked for the factoring. It's not so much the factoring out of the greatest common factor, it's the factoring of this portion. So what makes this difficult is that we have another coefficient besides 1 in x squared. Whenever we're dealing with just x squared, we can always just say, okay, I'm looking for two terms that multiply to equal my c term that add up to equal my b term. But this coefficient here kind of throws a wrench in that. In Algebra 2, I taught you a box method. Okay, and I'm going to use the box method to solve this. So I draw my box, and I put 3x squared up in the top left. That's my term for a. I'm going to put a minus 20 in the bottom right. Okay, and the first step of the box method is to multiply these two out. When I multiply them, I get a negative 60x squared. Okay, and that is what I am trying to find two terms that multiply to equal a negative 60x squared, but they need to add up to a positive 11x. So off of that, since it's a positive 11x, I'm going to use the two terms 15x and negative 4x. Okay, when you multiply those, you do get negative 60x squared. When you add them up, you do get a positive 11x. So those are the two terms. Once I have these, I'm going to place them inside the box. Okay, and I'm going to bring everything with them, the signs included. So now I have both rows completed and I have both columns completed. Now, once I'm at this step, I factor out the greatest common factor of each row and each column. So working row 1, which is the top one, I have 3x squared and 15x. So 3x goes into both of those. That's the greatest common factor that's shared between them. Looking at this bottom one, I have a negative 4x and a negative 20. That's going to give me a negative 4. Okay, 3x squared and x, negative 4x. The greatest common factor there is just the variable of x. And then 15x and negative 20, that is going to be 5 between those. And these make up my binomials. One of the benefits of using the box method is if I multiply these out and I just check, x times 3x does give me 3x squared. 5 times 3x does give me 15x. X times a negative 4 does give me a negative 4x. 5 times a negative 4 gives me a negative 20. So my complete factored form is x cubed, 3x minus 4, and x plus 5. Okay, what does this represent to us? This means that we have zeros on each one of these areas, and that comes from the zero product property, stating that if we set each one of these equal to 0, that's going to give us a root or a real zero that occurs in our polynomial function. So x cubed, if it's set equal to 0, I take the cube root of both sides. I'm going to find that x is equal to 0, and this has a multiplicity of 3. Okay, so 1, 0 has a multiplicity of 3. Since it is an odd multiplicity, that means when I touch my x-axis at 0, my graph is going to switch signs. It switches signs for each time we have odd multiplicity. If it's even, is when it kind of comes down from quadrant 1 and then touches and then bounces back up into quadrant 1, where we have no change in sign in the y value. But since this one has odd multiplicity, this one, it will change signs. My next 0 comes from 3x minus 4. If I set that equal to 0 and I solve for x, I get plus 4 on both sides. Cancel those. Left with 3x is equal to 4. Then I divide by 3 on both sides. And I get that x is equal to a positive 4/3. Okay, so that's one of my zeros. The final 0 is coming from when I set x plus 5 equal to 0, and I solve for x. I get x is equal to a negative 5. Okay, so I have a 0 here at x equals 0. I have a 0 here at x equals 4/3, and I have a 0 here at x equals a -5. So if I were to plug these into my original polynomial equation, they would all equal 0. Okay, once again, since all of these had odd multiplicity, there's going to be a sign change, which means that they're actually going to cross the x-axis. Okay, it's not going to come down and be tangent. That only happens when we have even multiplicity. But she asked about the factoring, and I imagine, Leah, that it was because we had the 3 up here. And if you're looking at it, kind of really doesn't make a whole lot of sense. But if we FOIL these out, there's 3x minus 4 and x plus 5. If we multiply those by using FOIL, so 3x times x is 3x squared. 3x times 5 is a positive 15x. Negative 4 times x is negative 4x. Then negative 4 times 5 gives me my negative 20. Combine my like terms, I get 3x squared plus 11x minus 20. Okay, but this one makes it difficult because of the value of a. If it's just 1, it's pretty simple, pretty easy. But since it's a value different than a, we have to take that into consideration when we are factoring. And the box method does a pretty decent job of that. Okay, so now we're off to the bell work. Your bell work question, it's an exponential. It's an exponential function. But we can, and I know we haven't covered exponential functions yet, but we can apply some things that we know already to make this very easy to solve. So it says the function f is defined by the equation above, which is f of x is equal to 2 to the x power plus 1. Since the exponent has the variable, that's what makes it an exponential function. Which of the following is the graph of y equals negative f of x in the xy plane? So here we're going back to our transformations of functions. Okay, this negative on the outside here means that this graph is going to be flipped over the x-axis. Okay, so it's flipped over that way. It's kind of like having a negative a value when you're talking about a quadratic. It flips it over the x-axis. So looking at this, I really only have to find one point on my original graph. And the point I want to find is my y-intercept. One, because that's the most clearly labeled one on the graph because they don't show any of the other grid marks. There's no other dots to really show a point. So what would my y-intercept be on my original graph? Get my chords out of the way here. This is very different, but so I have f of x is equal to 2 to the x power plus 1. So, and I want to find f of 0. So I plug it in. That's 2 to the 0 power plus 1. What you'll find, anything to the 0 power, okay, it could be a binomial term. It could be a million to the 0 power is always going to equal 1. So this equals 1 plus 1 for 2. So I have a point 0, 2, and it's going to be flipped over the x-axis. So I'm looking for a graph that has a point 0, negative 2. Okay, and looking at that, the only graph that has that point represented is equal to c. So I can solve this without having any real knowledge of exponential functions. Okay, but the correct answer is going to be C on the graph, on the belt, I mean. Okay, so here comes the fun part. We're off to lecture. We've already taken care of our self-evaluation. Wednesday is going to be kind of like last Wednesday. All I'm going to assign to you is the mastery check and the self-evaluation. It's because with everybody being at home, we got to kind of, as much as I don't want to, we got to kind of slow down a little bit. This is a prime opportunity for those of you who have missing assignments, though. Okay, it's prime. you're going to knock out your self-evaluation. You're going to knock out your mastery check. And then you are going to, I just got a chat. Where did it go? And better, it keeps kicking me out. Okay, Rosalind, I'm recording this and I will post it. So try to do your best. Did you let Mr. Baker know to see if the school can help you out with internet? Like I was saying, this is a prime time if you have missing assignments to try to get caught back up. Okay, it's very, very good. I'll still accept all the late work for missing full credit. So don't spoil the opportunity. I know it kind of sucks because we really wanted to stay in school the best that we could. It's just kind of the world that we live in. We're being told by powers outside of us that we're not allowed in. So we're just going to deal with it. We're going to get through November, have a beautiful Thanksgiving, and then we're going to have a great Christmas. All right. So 5-minute check. It says, first question is a graph f of x, which is equal to x minus 2 cubed plus 3. So on this, once again, we could plug it into a graphing calculator and we could be able to figure it that way. We could plug it in tables, but in all reality, we have everything that we need here to solve it just looking at our equation, right? But the plus 3 on the outside means that our graph is shifted 3 up, okay? The parent function, which is x cubed, always crosses through the origin, okay? So 0, 0 is where this little flat piece would be. So we're looking for one that is plus 3 up. So that eliminates D and that eliminates C. But now we have a horizontal translation coming from the inside of this x minus 2. Since it is x minus 2, that shifts our graph to the right 2. If it was x plus 2, it would be shifted to the left. Since it's shifted to the right, that eliminates option B, and our answer should be letter A. Okay, once again, you could create a table, you could set this up graphically, but if you can get good at analyzing these equations and realize the patterns that happen, you can solve these problems very quick, very easy. The next one, it says, describe the end behavior of the graph of f of x, which is equal to 2x cubed minus 4x plus 1 using limits, and explain your reasoning using the leading term test. So everything that we need is contained right here in this first term, this 2x cubed. So A is positive, but our degree is odd. So anything with an odd degree always starts low and ends high, especially if A is positive. If A is negative, an odd degree starts high and ends low. So we're looking for an answer option that has the limit as x goes towards a negative infinity, f of x is equal to a negative infinity, and the limit as x goes towards a positive infinity, f of x is equal to a positive infinity, because that's just the very proper mathematical way of saying, hey, my graph's going to start in the bottom left, and it's going to go until the bottom right. So looking at them, I'm going to choose answer C. It says the degree is 3 and the leading coefficient is 2. Because the degree is odd and the leading coefficient is positive, limit as x goes towards a negative infinity, f of x is equal to a negative infinity. That checks out. And the limit as x goes towards a positive infinity, f of x equals positive infinity. So that checks out as well. So answer C is the correct one. Okay, here we got to determine all the real zeros of f of x, which is equal to 4x to the 6th minus 16x to the 4th. So here, just talking about real zeros, remember the number of zeros comes from the highest exponent. So since it's 4x to the 6th, that means that our graph potentially could have 6 real zeros. Could have. That's the maximum. Not saying that it will have, saying that it could have. And since my highest coefficient is 6, or my highest degree is 6, that means this graph could have up to 5 turning points. Okay, so your leading exponent tells you a lot. How many zeros is equal to the highest exponent? How many turning points is equal to the highest exponent minus 1? So we could have 6 real zeros, and 5 turning points, but this fits the form of the quadratic. So we need to factor it. So we have 4x to the 6th minus 16x to the 4th. And the first step with everything, we're going to try to factor out a greatest common factor. We do want to take the coefficients into play here. So 4 does go into 16. So we know we're going to have a 4 on the outside. That's the greatest common factor between the coefficients. Now looking at our exponents, we have x to the 4th and x to the 6th. That means we can bring out x to the 4th. And once we divide that, 4x to the 4th or 4x to the 6th divided by 4x to the 4th leaves us x squared. And this is going to be minus 4. Okay. So this on the outside is going to be 1 real 0. And then when we factor this down, we're going to have 2 more real zeros. This is what's known as difference of squares, because each of these terms is a perfect square. Okay, x squared and 4. X squared is a perfect square where the square root of it is x. Okay, and 4 is a perfect square where the square root is 2. That's going to leave us x plus 2 and x minus 2. So this is the total factored form. Once again, we have to apply the zero product property, where we set each one of these equal to 0 and solve for x. So x minus 2 set equal to 0, solve for x is going to give you x is equal to 2. X plus 2 set equal to 0, and then solve for x is going to give you x minus 2. And then 4x to the 4th set equal to 0. Okay, we would divide by 4 first. So that's x to the 4th is equal to 0. And then we would take the 4th root. Once again, this is just kind of busy work to show that x is equal to 0. What you'll find is because of the zero product property, any term that's really set out on the outside corresponds to the origin. Okay, because anytime 0 divided by anything is still just going to be 0. The 4th root of 0 is still just 0. The 6th root of 0 is still just 0. The 5th root, the square root, the cube root, all of those really correspond to being 0. And like I said, as you get more comfortable and more familiar with these, your greatest common factors, as long as there is a variable associated with it, will most always show to x being at 0. So what does this mean? Is that this 0 has a multiplicity of 4 because it's associated with the 4th root. Then we have another 0 at negative 2 and positive 2 that have multiplicity of 1. So if we go back to our slides, we're looking for an answer option that has 0, negative 2, and 2, and only those, and that corresponds to answer A. All right, so before I get too deep into this, I got a question for you guys. Me writing on the document camera, you guys able to make everything out? I don't want to go through and post this lecture and then have a whole bunch of people saying that, oh, I couldn't read it, stuff like that. So if there's a problem with it, could you let me know through the chat? If you don't respond to anything, I'm going to assume I'm doing great. That way, if there is a problem, hopefully I can get it resolved in the next 55 minutes. That way we can actually have a productive session today. I think it is good. Thank you, Leah. Awesome. That's the biggest pat on the back. That's what I needed. Needed that positivity in my life. All right. So here's what we have. We have then, you factored quadratic expressions to solve equations. That was lesson 03. Covered factoring. Once again, that's when I showed you the box method. Factoring again appeared in the last section. So today what we're going to cover is we're going to divide polynomials using long division and synthetic division. And that's a long-winded way of saying that we're going to factor polynomial equations, but they're going to give us a factor. Okay, and that's what allows us to use long division and synthetic division. Okay, and then we're going to use the remainder and factor theorems. Those come wholeheartedly from synthetic division. Okay, so the difference between these two is long division and synthetic division. They do the same thing, just one's really quick and efficient, while one is kind of a little long and drawn out process. This is something that I taught you in Algebra 2 in regards to long division and synthetic division, but the remainder factor theorems are just applications of how these work. Okay, so the new vocabulary, synthetic division. Depressed polynomial is the quotient after you've done long division or synthetic division. And then synthetic substitution, once again, it's all centered around using synthetic division. Okay, so here we have our first one. Some keys to using long division to factor polynomials is we want to make sure that each one of our terms are represented and that they are accounted for. Okay, so what that means is here I have the highest degree of 3, right? I have 6x cubed as my leading coefficient. So from there, working to the right, I should have a variable that is x squared. I should have a variable that is to the x, and then I should have a constant. Each one of these terms needs to be represented. If any one of these is missing, I'm going to plug that in as a 0 associated with that given variable. So and I think there is one in the slideshow, so I'll cover that a little bit more when we get there. Just we want to make sure that they are in order, in exponents from greatest to least, and that each step is represented. So we can't go from x cubed just to an x. There has to be an x squared. We can't go from x to the 4th to x squared. There has to be an x cubed. Okay, so that we got to be very detailed when it comes to this. So I have 6x cubed plus 17x squared minus 104x plus 60. And I am dividing by 2x minus 5. Okay. So here we go. This is what we have. It's my divisor. This is dividend. The answer will be the quotient. Okay. And the way long division works is I want to focus on my x values. Okay. I want to know what I have to multiply 2x by to equal 6x cubed. So then when I subtract, because long division, the process doesn't change. We're always going to be subtracting on the bottom side so that I no longer have any variable that's associated with x cubed. So 2x, to get to 6x cubed, I need to multiply it by 3x squared. Okay, 3x squared times 2x does give me 6x cubed. But then you can see I have this other term that's represented in the divisor. Since I multiplied these two, I have to multiply this as well. So 3x squared times a negative 5 is negative 15x squared. Okay, and then I'm going to subtract. So 6x cubed minus 6x cubed leaves me with 0. That's what I'm looking for. 17x squared minus a negative 15x squared is going to give me a positive 32x squared. Okay, and then at this point, the same principles of regular long division, I drop down this term. So I get a negative 104x, and I want to bring the signs as well. So then I ask myself the same question. What can I multiply 2x by to get 32x squared? Okay, and the answer to that would be a positive 16x. 16x times 2x gives me 32x squared. 16x times a negative 5 is a negative 80x. Okay, and then I'm going to subtract again. So 32x squared minus 32x squared once again gives me 0. 104x, a negative 104x, subtract or minus a negative 80x is going to give me a negative 24x. Okay, and you'll see that I have to bring the terms. I have to bring positives, negatives, everything with that. And then I'm going to drop down my last term, plus 60. So what can I multiply a negative 2x by to get a negative 24x? And that is negative 12. Negative 12 times 2x is a negative 24x. Negative 12 times a negative 5 is a positive 60. And then once again, I subtract. Negative 24 minus negative 24 gives me a 0. 60 minus 60 gives me 0. Okay, this is key. Showing the zeros at the bottom because I'm left with no terms. You're very familiar with a remainder, something you would have covered in elementary. Since my remainder is 0, that is showing that this is a true factor. Okay, it is a true factor of this polynomial. So once this is done, I have 2x minus 5 and 3x squared plus 16x minus 12 as one, it's a factor, and then this is what's known as the depressed polynomial. Okay, so we're given that factor. We found our depressed polynomial. To truly finish off this question, we would have to factor this. Okay, we would have to factor this out. Okay, once again, since my term of A is something different than 1, I'm going to use my box. So 3x squared goes there, minus 12 goes there. I multiply those together to get a negative 36x squared. Okay, so I'm looking for two terms. Oh, I forgot an x. 3x squared plus 16x minus 12. So I'm looking for two terms that multiply to equal a negative 36x squared that add up to equal a positive 16x. And the two terms that come off to mind are 18x and a negative 2x. Okay, so once I have those, I fill out my box. Okay, and then once again, I'm just factoring out the greatest common factor, starting with the rows and then the columns. So I have 3x squared and 18x. Greatest common factor between those is going to be 3x. Negative 2x and 12. Greatest common factor is going to be negative 2. 3x squared and negative 2x. The greatest common factor is just the variable of x. 18x and 12 is going to give me positive 6. Okay, and then once again, the beautiful thing about the box, if you bring the negatives and have all the positives associated, you can always double check yourself. X times 3x does equal 3x squared. 6 times 3x is 18x. X times a negative 2 is negative 2x. 6 times a negative 12 is negative 12. So my final factored form is 2x minus 5, 3x minus 2, x plus 6. Okay, we don't necessarily have to carry it out to the zero product property. Okay, where we would set each one of these equal to solve. Well, we can get a pretty good idea. This set equal to 0 and solve means I have a 0 at negative 6. This one here means I have a 0 at 2/3. This one here means I have a 0 at 5/2. Okay, and once again, that's coming from the zero product property, where we would set those each equal to 0 and then solve. That's not going to be a mandatory thing. I just want to reinforce that that's what those mean. Okay, this right here is what we're looking for. Okay, so we divide it to get our depressed polynomial, and then we factor our depressed polynomial. Here's the book steps again. So 2x minus 5 gives us, that's them just setting up the equation. Okay, once again, they're trying to figure out what can they multiply 2x by to get 6x cubed. That's 3x squared. Once they found this term, they multiply it by both terms in the divisor to get 6x cubed and negative 15x squared. Okay, then they subtract and bring down the next term. Once again, they're trying to figure out what could they multiply 2x by to get a positive 32x squared, 16x, and then they multiply both of those terms. Then they subtract. Then they find that you can multiply it by negative 12. Remainder 0. Okay, that shows that 2x minus 5 is a true factor. Okay, from this division, you could write it out here. And then factoring the quadratic expression. So that's the complete factors. 2x minus 5, 3x minus 2, x plus 6. Okay, we're trying to get it down to its complete factors. So we use long division to get the depressed polynomial. Then we factor that depressed polynomial. So a lot of algebra in this one. Okay, we'll do this one. So 6x cubed plus x squared minus 117x plus 140. That is all divided by 3x minus 4. Okay. So once again, I want to make sure that since my leading coefficient is to the third power, that each term is represented. So I go from x cubed to x squared to x to constant. That's perfect. Okay, it's all in order. I need to have it in order from exponents highest to lowest, and that each exponent is represented. It doesn't work if I don't. Okay, so 3x, what do I need to multiply that by to get 6x cubed? The answer to that is 2x squared. 2x squared times 3x is 6x cubed. 2x squared times a negative 4 is negative 8x squared. Then I subtract. So I get a 0 there. Positive x squared minus a negative 8x squared is 9x squared as a positive. Bring down my next term, 117x. 3x, to get a 9x squared, I would need to multiply again by a positive 3x. So 3x times 3x is 9x squared. 3x times a negative 4 is a negative 12x. And then I subtract. 9x squared minus 9x squared is 0. 117x minus a negative 12x is negative 105x. Yeah, yep. There, bring down my 140. Okay, what would I need to multiply 3x by to get a negative 105x? And the answer to that is negative 35. 3 times 30 is 90, times 5 is 15. That checks out. It's negative 105x. 35 times a negative 4 is, that's 120. It's a positive 140. 0, 0. Okay, once again, since I have a remainder of 0, that shows that 3x minus 4 is a true factor. I keep saying that because some of your questions are going to ask you to find out if this is a factor. Okay, from here, I have my true factor, my depressed polynomial. Okay, I'm going to use my box to factor my depressed polynomial. 2x squared negative 35. It's looking for two terms that multiply to equal a negative 70x squared that add up to equal positive 3x. Okay. Well, that's not easy. 35 and 2. Negative. Oh, positive 35x and a negative 2x. But multiply those, they do equal a negative 70x squared. Nope, that's going to be 33x. That doesn't work. Okay, so I kind of hit a block point. So I'm looking for two terms that multiply to equal a negative 70x squared. So I'm just going to start counting factors. I have 1 and 70, add up to 69 or 72 and 35. Okay, 3 doesn't go into it. 4 doesn't go into it. 5 does. What do I need to multiply 5 by? Maybe somebody in the chat's helping me out. Ah, good job, Rosalind. Good job. Thank you for that. She gave me 10x and a negative 7x. Perfect. Good job. But they're not going to come to you straight off the top, right? So in the event that you hit a block just like I did, thank you for the lifeline, Rosalind, but you can always count out factors like that. So I would have kept going, and then I would have eventually found these two. And the things I'm looking for is that they multiply up, and what do they add to? These could add to be 69 or 71. These could add up to be 33 or 37. And it's really just kind of check, guess and check. Rosalind, thank you again. But we want to make sure that we're finding the correct factors. Check them out. 10x times a negative 7x does equal a negative 70x squared. And they do add up to a positive 3x. So those check out. Negative 7x. And then once again, I'm factoring out the greatest common factor. So 2x squared and 10x is 2x. Negative 7x and a negative 35 is a negative 7. 2x squared and 7x is just the variable of x. 10x and 35 is going to be a positive 5. And then I can always double check myself. X times 2x, 2x squared. 5 times 2x is 10x. Negative 7. Perfect. So my factors in true factored form are listed right there. So 3x minus 4, 2x minus 7, and x plus 5. Perfect, Rosalind. Thank you so much. And that was the answer. Okay, so let f of x, d of x be polynomials such that the degree of d of x is less than or equal to the degree of f of x, and d of x cannot equal 0. Okay, that's because we're dividing. Then there exist unique polynomials, q of x and r of x, such that f of x divided by d of x is equal to q of x, which is plus the r of x over d of x. Okay, that's a lot of mathematical verbiage to just establish a remainder. Okay, so f of x is the function that the whole polynomial function. So in that last question, it was 6x cubed plus x squared minus 117x, right? So it was that last function that this would be f of x. here, the 6x cubed plus x squared minus 117x plus 140. What we divided by 3x minus 4 is d of x. Okay, so we're given the total function, we're given the factor that they want us to check, and then once we get that, we get q of x. Okay, q of x is the quotient, or the answer, or the depressed polynomial, what's left. Okay, r of x in this case would be the remainder. So the two problems that we had, or the three problems that we've had remainders of 0. Okay, that's not always going to be the case. Whenever we get a remainder, this r of x, we express it over d of x. Okay, so it's kind of the same thing that you did in long division, where you would express the remainder over the divisor. And that would correspond to like a fraction. Okay, so when r of x is equal to 0, the degree of r of x is less than the degree of d of x. If r of x is equal to 0, then d of x divides evenly into f of x. So f of x is your whole polynomial, d of x is the divisor, q of x is the quotient that you get, or the depressed polynomial, and then we express the remainder over our divisor. Okay, so here we're going to set it up. Okay, I'm not going to walk through this one algebraically. We're just going to click through it because we still got to get through synthetic substitution or synthetic division. So they find 3x squared. They do all their multiplication. They multiply both terms in the divisor. Then they do their subtraction. Okay, negative 5x squared minus a negative 3x does give you a negative 2x squared. And then they multiplied 2x by x to get a negative 2x squared. Okay, plus 9. So they carry out their long division process. Okay, and you can see that once they've done all of their long division through the last term, they have a remainder of 10. Okay, in the event that this happens, we want to express our answer as the remainder over the divisor, the same way that you would do in regular long division. Okay, what this does is it sets up an x value that you cannot have. X can't equal 1/2, because if we plug in 1/2 here, our divisor, this 2x minus 1, turns into a 0, which makes it undefined. Okay, so that'll be your answer right here. But then they're going to ask you to multiply it, or multiply to check. Okay, the beautiful thing is when you multiply. So when you multiply, you have to multiply by the divisor again. Since you're dividing by the divisor in the remainder, and since you multiply by the divisor, that's just going to leave the constant. Okay, those two terms cancel out. Okay. And then they carry out all the rest of their multiplication to find that they end up back at the original polynomial. So whenever you have a remainder, we express it over the divisor. Okay. So here, division by a polynomial of degree 2 or higher, the process stays the same. Okay, the process stays the same, just you're going to be jumping. Okay, we want to look at what makes x squared equal to this x cubed. I'll just go ahead and do this one. We got to get there though. X cubed minus x squared minus 14x plus 4, all terms represented. Perfect. X squared minus 5x plus 6. This is a longer one than I really wanted it to be. So once again, I'm going to be looking to find out what I can get my highest degree to equal this term. So if I multiply this by x, that checks out. So x times x squared gives me an x cubed. X times a negative 5x squared gives me negative 5x squared. X times a positive 6x gives me a positive 6x. Just like that. That cancels out to 0. And then I subtract negative x squared minus 5x squared gives me positive 4x squared. Yep. Perfect. Negative 14x minus a negative 6x gives me negative 20x. Plus 4, bring that down. Okay, then the process just repeats itself. What can I multiply x squared by to get 4x squared? And the answer to that is a positive 4. So that's 4x squared minus 20x plus 24. Do my subtraction, 0, 0, negative 20. So my answer would be x plus 4 plus a negative 20 over my divisor of x squared minus 5x plus 6. So it's the same process. It's almost a little bit easier because you can only find so many terms. But we just want to be sure that you're carrying out the process. It all centers around trying to find how to cancel out the highest degrees. Okay, so here they multiplied by their x. They do their plus 4. Okay, and then they can write that as the answer. That would be their answer. Okay, understand that if there's a remainder, it's stating that it's not a true factor, so we can't go any farther than that. Okay, so we don't have to factor those ones. We got to get to some synthetic division. Perfect. Okay, synthetic division. So it breaks itself down into 4 steps. It says to divide a polynomial by the factor x minus c, complete each step. It says write the coefficients of the dividend in standard form, write the related 0 of the divisor x minus c in the box and bring down the first coefficient. So the related 0 of the divisor x minus c, so that is, if we were to set it equal to 0 and solve for x, what would that value be? Okay, so in this case, our example, we're given x minus 3. If we set that equal to 0 and we solve for x, we get the value of 3. Or in other words, it's always going to be the opposite. So this is x minus 3, so we use c, or we use 3. If it's x plus 3, we're going to use negative 3. Okay, after we have it all written out, we drop the first coefficient down. Okay, and then we multiply, and then we add. We multiply, and then we add. And we're always multiplying by this value to whatever is beneath here. Okay, and then whatever is represented under our last term is our remainder. Okay, once again, this is something that we've done before, but it makes it very fast. So first step is just write the coefficients. Also, double check to make sure that each term is represented. Okay, so x to the 5th, x to the 4th, x to the 3rd, x squared, x minus 8, that's perfect. So I have 2, negative 4, negative 3, negative 6, negative 5, and negative 8. They really like negatives here. Okay, and my c value is 3. So once again, I'm using the opposite. It said we wanted to divide by x minus 3, and then we wanted to use synthetic division. So if I set this equal to 0 and solve for x is equal to 3, which is why I'm using a positive 3 instead of a negative. Or if you like thinking in terms of opposite, you use the opposite whenever you're given there. So this is x minus 3. I'm going to use a positive 3. I can set it equal to solve. Do it that way. Okay, first term, I drop down. Okay, and then I multiply these two terms. 3 times 2 is 6. I bring that there. Okay, so I multiply to get that. Negative 4 plus 6 is a positive 2. So I add down, I multiply. 3 times 2 is 6 again. Bring that there. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 6 plus 9 is positive 3. 3 times 3 is 9 again. I add, I get a, where did I go wrong? 6, 6, 3. I'm going to have a remainder. So negative 5 plus 9 is 4. 3 times 4 is 12. I have a remainder of 4. So what those represent is coefficients. Okay, these represent coefficients of my new depressed polynomial. Okay, the key thing is, now I'll bring you back to the original one real quick. You can see how I started at 2x to the 5th. Okay, the degree of my answer is always going to be 1 less. Okay, right here. Step 4. The numbers along the bottom row are the coefficients of the quotient. The power of the first term is 1 less than the degree of the dividend. And the final is the remainder. Okay, so since in the example it started with 6x cubed, this is going to be 6x squared. Here we started with 2x to the 5th. Okay, and this is the process that we just went through. C is 3. We set up the division as follows. Then we drop it down. We multiply. We add, multiply, add, multiply, add, multiply, add, multiply again, and add. Okay, so that's basically what I just did. We had 2, 2, 3, 3, 4, 4. Our answer, since this one is x to the 5th, this is going to be 2x to the 4th. Then it's going to be 2x cubed. Then it's going to be 3x squared. Then it's going to be 3x. Then it's going to be plus 4. Okay, so our answer starts 1 degree less than the answer than what we were given to divide. So if we're given 2x to the 5th, our answer is going to start with x to the 4th. Okay, we have to subtract 1. Okay, and here's the example. You can see the coefficients. We had 2, 2, 3, 3, 4, 4, with 4 being the remainder. So our answer is 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4, with 4 being over our divisor as a normal remainder. I haven't filled them out yet, but knowing that I started with 2x to the 5th, then yes, I have 2x to the 4th. This is plus 2x cubed. This is plus 3x squared plus 3x plus 4, with 4 over x minus 3. Okay, that's kind of the caveat with synthetic division. is that your degrees always have to start one less than what you started with. Okay, but you can see that's a much faster process. It's a much faster process for you. Okay. In the event that they give you, and they ask for synthetic division with a coefficient of, where this coefficient here is not just 1. Honestly, the work involved to get it set up so that you can use synthetic division, it's more work than doing it long division ways. So in this case, I would just carry this out using long division. They're going to show you how to do it on synthetic division. More or less what you have to do is you have to divide by that coefficient. Okay, I'm not going to ask you to do this. We will only do synthetic division when it's set up with terms like x minus 3. Okay, if it's anything other than a 1 associated with that x value, just use long division. Okay, so here is them getting it set up. They have to divide by 4. So you can see each one of their coefficients, they've divided by 4 and simplified, which brings in the element of fractions. And then they would carry out their synthetic division, which is just more work than is necessary. In that situation, just use long division. Okay, so the remainder theorem. This centers all around synthetic division, just like the last one. Okay, what it says if a polynomial f of x is divided by x minus c, the remainder r is equal to f of c. So in other words, you can do synthetic division as a way of finding function values. So instead of actually plugging it in and carrying out all the math that way, you can do synthetic division to solve for function values. Okay. So here's our real estate, our real world example. It says, suppose 800 units of beachfront property have tenants paying $600 per week. Research indicates that for each $10 decrease rent, 15 more units would be rented. The weekly revenue from the rentals is given by the following. So we have negative 150x squared plus 1000x plus 480,000, where x is the number of $10 decreases the property manager is willing to take. Use the remainder theorem to find the revenue from the properties if the property manager decreases the rent by 50. So x is the number of $10 decreases. We're trying to figure out what it would be if we decreased the rent by $50. So we're going to be using 5, okay, or x minus 5. So basically what it's asking you is take this polynomial and we want to divide it by x minus 5. Okay, essentially what it's asking you, but since it has the remainder theorem, we can set this up using synthetic substitution. So x minus 5, I use 5. I have a negative 150, positive 1,000, and I have 480,000. Okay, then my synthetic division process just carries on. So I drop down my first term, get negative 150 times 5 is a negative 750. And then I add to give me a positive 250. And then I multiply again. 250 times 5 is 1250. Okay, and then I add going down. So that is 481,250. This would be my remainder. Okay, so what this means is that f of 5 is equal to 481,250. So in other words, if I plug 5 into this polynomial, I would get 481,250. Okay, and that's the remainder theorem. So this is what's known as synthetic substitution. So here they've set it up. They drop down the first term, they multiply, they add, they multiply, then add. So 481,250. So f of 5, or if you plugged 5 into that original polynomial, you would get $481,250. Okay, it's just a quick way to do this, so you don't always have to plug it in. Okay, you can always check your answer using direct substitution by plugging 5 in. 5 squared is 25 times negative 150. That's negative 3,750 plus 5,000 gives you 1,250 plus 480,000 gives you 481, 1,250. Okay. So for this one, since it's real quick and I gotta do one more using. So it says, use the equation for R of X from example 5 in the remainder theorem to find the revenue from the properties if the property manager decreases the rent by $100. We have to remember that X represented $10 increases. So we're going to be using X minus 10 to do our synthetic substitution, but the coefficients don't change. So setting it up, 10, negative 150, 1,000, 480,000. Drop your first term down. Multiply negative 150 times 10 is negative 1,500. Add gives you a negative 500. Multiply again. It's a negative 5,000. Add those to find 475,000. So we add going down, multiply going up, add going down, multiply going up, add going down. So 475,000. So f of 10 is equal to 475. Okay, so the factor theorem. The same way that if we get a remainder of 0, the same thing applies to synthetic substitution. So, and that's what the factor theorem states. It says a polynomial f of x has a factor x minus c if and only if f of c is equal to 0. So that's that's bringing in the remainder theorem and the factor theorem as well. So from the remainder theorem, we found out that we could use synthetic substitution to plug in and find the answers quickly. So the factor theorem says that once we plug in those values, we'll get 0, which shows the true roots or a real 0 of the equation. So if f of c is equal to 0 or a remainder is equal to 0, that means that it's a true factor of the polynomial. So use the factor theorem to determine if x minus 5 and x plus 5 are factors of x cubed minus x squared plus 60x. Okay, these ones have coefficients of 1. So we can do this very simply. Okay, and we can do it very easily using synthetic division, synthetic substitution, however you want to look at it. So on the top, we'll do x minus 5. On the bottom, we'll do x plus 5. We have x cubed minus 18x squared plus 60x plus 25 x cubed minus 18x squared plus 60x plus 25. All right, so I got them set up. Okay, so here we're checking this factor. So once again, we got to determine what C would be. So if I set this equal to 0 and solve, I find that x is equal to 5. So on the top, I'm using 5 as my value of C. And then I bring down my coefficients. So I have a 1, a negative 18, positive 60, and a positive 25. Okay, each term is represented, so I don't have to plug in a 0. That's perfect. So I drop down my 1, I multiply to find out that that's 5, and then I add. Negative 18 plus 5 is negative 13. Multiplied by that, that's a negative 65. I add again. It gives me a negative 5. 5 times negative 5 is negative 25, giving me 0. So what that means is that x minus 5 is a true factor, okay, of that polynomial. Okay, it is a factor. Okay, but the question asks me to check if x minus 5 and x plus 5 are. So here I'm going to do the same thing. So my factor that they want me to check is here. So if I set it equal to 0 and solve, I find that I'm going to be using negative 5. So negative 5 is my value of C. I have 1, negative 18, positive 60, and a positive 25. Okay, bring down my first term. Negative 5 times 1 is negative 5, and then I add. So that's negative 23. That gives me then I multiply that against negative 5. Gives me a positive 115. Plus 60 is a positive 175. Right here, it's pretty clear that this isn't going to add up. But negative 5 times a positive 175, that's 500. 5 times, that's 500. That's 350, negative 875. That's what I think. Negative 5 times 175. Yeah, negative 875, and then I add those up to find that I get a remainder of negative 850. So x plus 5 is not a factor. Okay, but what this means at the same time is that using the remainder theorem is that f of 5 or f of negative 5 is equal to a negative 850. Okay, so that's saying if I plug negative 5 into this equation, I would get negative 850. Up here, if I were to plug 5 into this same equation, f of 5 would be equal to 0. Five more minutes to walk through their stuff. I've already assigned the homework. So, and that's the last thing that I needed to show you. I'd stay on just for the last slide. I'll let you guys copy that down because it gives you a couple quick tips. So here they're using 5 or this factor. So you can see the remainder is 0. Okay, here they're using negative 5 or as x plus 5. They get negative 850. So when it's divided by x minus 5 is 0, so f of 5 is 0, and x minus 5 is a factor. When f of x is divided by x plus 5 is negative 850, so f of negative 5 is negative 850, and x plus 5 is not a factor. Okay. Last slide that I wanted to show you is right here. So this is basically setting up all of the tips and tricks, or it's just a key concept to help. It's a summary. So if R is the remainder attained after synthetic division of f of x by x minus c, then the following statements are true. R is the value of f of c. If R is 0, then x of c is a factor of f of x. If R is 0, then c is an x-intercept of the graph of f. And then if R is 0, then x equals c is a solution of x, f of x equals 0. So any questions, anything like that before I turn you straight loose and in the Zoom call? I know it's a lot. It's stuff that we've done before, so I don't anticipate too many problems. But like I said, next week, on Wednesday, all we're doing is a self-evaluation and the mastery check. So if you have any questions, make sure that you're asking them. Okay, your homework, I'm going to ask you to have it done by Wednesday. Have it done by Wednesday by the time we come to class. Okay, that way your self-evaluation is actually useful. I'm going to give you quite a bit of time, and then I want to spend a little bit of time answering questions is how I want to spend Wednesday's class. Okay, so come ready, making sure that you have all your stuff done.